Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 8, Lesson 3, Exploring Sine Graphs, Part 2. Now, in the first part, we talked about the equations. Y equals a sine of x plus d, and how you can calculate the amplitude, the midline, from the graph, and from the equation, the maximum minimum from the equation. Here, we're going to go on to graphs and look at them. So, range amplitude equation, excuse me, equation of the midline and period of this graph. Excuse me. Now, first things first, let's go back. Range is my y values. So that's a fancy way of saying what's my maximum, what's my minimum. So the range, well, notice the graph, and I apologize, this is not, it's a good graph, but it's a little fuzzy here. I think your copy should be a little clearer. I want you to see that the minimum is down here at -1. And the maximum is up here at +9. So this is -1 is less than or equal to y is less than or equal to 9. So that is the fancy way of saying min -1, max is 9. Now, going on, equation of the midline, d, also amplitude, my apologies, I missed that, amplitude equation of the midline. So here, we have to find the middle. So -1 to 9, most of you guys can eyeball it and go here. Now remember, we did give you the formula from the graph. A equals max minus min. So the maximum, and that's why we figured out the range or the maximum first. 9 minus -1, 2. Notice it's max minus min. I always screw that one up, so I have to check the formulas myself. But anyway, so that is 9 plus 1 over 2. So the amplitude is 5. And then we'll change colors. I'll make the purple. Displacement from the midline is max. So displacement of the midline plus min. How would you phrase that? The midline. 9 plus -1, 2, which is 4. So this midline should be equals 4, and it is. Notice I was sneaky and didn't label the axes. You've got to count. Yes. Now the amplitude, A is 5. It's going up or going down. Sometimes you have a choice here. Occasionally I'll just give you part of the graph and you have to figure it out. Now, so that's YAD. Oh, the period graph. Now, period, we mentioned somewhere along the way, is how long it takes to repeat. Now, I did that back in chapter, yes. Normally the period is 360 degrees. But this graph moved around, so we've got to check it. Now, I did give you the spiel about going peak to peak. Now, those of you that have taken physics have seen the symbol lambda, which is the lazy person way of saying wavelength, or period. So we were looking at the graph here. Now, in this example, it's not bad because this number, and this number I think we can figure out. If it's 180, that's, yeah. So each of these is 45, 91, so that's 225. So that's 225, that's 45, which is 180 degrees. So it's short. Stumpy, period. Now, some of you have taken physics, so you're going, no, Mr. Sutton, you showed us a different way, where you go from the middle, going up, and then we're the middle going up again, and from here, here, which is 0 to 180 degrees. So you get the same answer. So if you've taken physics or you remember Science 10, there's more than one way to measure the period. Choose one and stick with it. All right? That's what I need you to see and be able to do. Now, moving on. Here's another graph. Determine the range and amplitude equation, the midline and period of the graph. So, once again, not the nicest copy, but I realize on yours, photocopy shows up nicer. So, let's get through this quickly. Range. Minimum is 1, maximum is 5. Now, if you look at that, you're going, oh, my amplitude and my midline. Well, the middle is, looks to be about here. B equals 3. No. And if that's the case, then I'm going A equals 2 going up and going down 2. So A equals 2. Now, I should prove that algebraically, because A is max minus min. My maximum is 5 minus my minimum. 1 is 4 over 2, which is 2. Yes, I did eyeball it correctly. And please note, if I don't ask you to show work, like a multiple choice question or something like this, you can just eyeball it off the graph. I'm perfectly happy with that. It's just, yes, I got my D correct also. There's 3, and there's 3 in a while. Now, the period. So I did that kind of quickly, but you guys should remember all this. So the period is 1 peak to 1 peak, or, as many of you guys remember, 1 complete wave. From the middle, like that, go down, that is 5, 6, 7, 8. Now, this graph kind of sucks. So the grid line's going to suck, but I'd say it's about 8-ish. Now, I need you to be able to do that. Now, one side note, comparing cos and sine graphs. Now, the cos curve is the same curve as a sine graph, or the cosine curve. So, everybody grab your graphing calculator. We should do this. And y equals, I'm sorry, clear. How you put that? It's not that. So let's just do sine x. Sine x. There we go. Now, as I was talking earlier, when you graph these, what should you indicate? Who remembers? I did write it down somewhere. My notes. Yes. Tricks to graphing sine of x, 0 to 360. Windows, 0 to 360. I'm going to do this to every 30 degrees. The y minimum, I suggest minus 2. 2. And, oh, and mode. Am I in degree? Yes, I'm in degree. Graph. And there we go. That's our standard sine graph. Now, if you look at the graph here, I just drew this part of the sine graph. It's a very nice sine graph, but the color is not the greatest on the screen. It is better on your book, on your handout. Now, so looking at this, you clearly see the sine graph. Now, do the same thing for cos. Y equals, second graph, is cosine of x. Same window, same everything. Oh, I'm going to get fancy and make this thicker. Scroll over and hit enter, make it thick, graph. And there's the cosine wave. So as you start with cosine, it'll be cos of x, and this is sine x. Now, notice I did that for one wave or one period. If you look at the graph here, notice I kept on going both directions. I'm just lazy. But with a calculator, that's easy enough to change around. Window minus 360. There we go. there's our sine graph that keeps on going. Remember when we did this in 8.2, I warned you, the main x is all real, because you can make this window as wide as you want. You will still see a sine graph. Now, the important point to note here, the cosine curve is the same shape as the sine curve. Now, if you translate the curve to the right by 90 degrees, it will result in a sine graph. So, literally, take your cosine curve. I can do this, move it over, and you've got your sine curve. It just starts in a different spot. So, when you're looking at the graph, you really got to go, is that a sine or cosine? Boy, I got to tell you, because you really can't tell them apart without lots of practice. And that's why we use the generic term sinusoidal graph, because this is a sine graph. Oh, all right, be a fun second when I'm trying to do. Here's the sine graph moved. Here's the sine graph moved. Here's the same sine graph moved. And later I'll talk about moving it. That's the next lesson. The moment, notice, very identical curves, they just moved to the right. Now, actually, I should state that, to be more specific. Notice the cosine graph starts at a different place than the sine graph. The cosine starts at the maximum, and the sine starts at the middle. So the cosine, let me color code this is green, starts at the maximum. So if I tell you the graph starts here, by definition, it's the cosine. And if I tell you it starts in the middle, then it's by definition the sine. I know. Confusing. That's my brain. One thing you gotta remember. Now, and note here, we can talk about the x-intercepts, or the coordinates in degrees, or in radians. It's 90 degrees, 180 degrees, or pi over 2 radians, radians, and so forth. Alright? So be careful. Now, that leads to a typical trick question you'll see occasionally. Which of the following is not an intercept of the graph y equals sine of x? Sorry. No, I'll pause the recording here. I'll finish this question in the next video. This is getting too long. Any questions, shoot me an email. Otherwise, good luck. Good luck.